So we have the integral of 3x squared plus 1 divided by x cubed plus x squared plus x plus 1. Then we are taking the integral with respect to x. So let's see what do we have here. First of all, if you apply the method of partial fractions, we don't need any long division because the degree of the denominator, which is yours, so if you write it as px divided by qx dx, the degree of qx is equal to 3, which is more than the degree of the numerator, the degree of px, which is just 2. So no long division is needed. So now our goal is to break down the denominator into smaller pieces. Let us try to factor out the denominator. Our denominator is x cubed plus x squared plus x plus 1. So if I take the very first two terms, between these two, I'm going to factor out x squared. So I left with x plus 1. Between these two, I don't have anything to factor out. So I'm just going to copy down plus, I'm going to put x plus 1 inside parentheses. So now between these two terms, this guy and this guy, I can factor out x plus 1. So this can be written as x plus 1, which is a linear term, times x squared plus, if I factor out x plus 1, I end up with a 1. It's not 0. Well, we have a linear expression and we also have a quadratic expression. But for this quadratic expression, the discriminant, which is b squared minus 4ac, is equal to 0 minus 4, which is negative. So you cannot break x squared plus 1 into smaller pieces. So since our denominator is a product of a linear expression and a quadratic expression, our integral of px qx, or in general, let us write down just px qx, which is equal to, here we have, let me go up, 3x squared plus 1 divided by x cubed plus x squared plus x plus 1 can be written as, so here you have a divided by x plus 1 plus, now you need a linear expression like ex plus f divided by the quadratic part, which is x squared plus 1. So you have x squared plus 1. Now let me use a different color for this guy. Very good. Now, if you take common denominator on the right-hand side, the fraction on the right must be equal to the fraction on the left. So take common denominator. The common denominator is nothing but the multiplication of x plus 1 and x squared plus 1. So the fraction on the left-hand side and the right-hand side, they have the exact same denominator. Their numerators must be equal to each other. set the numerators equal. So the numerator on the left-hand side is 3x squared plus 1, and on the right-hand side you have a times x squared plus 1 plus x plus 1 times ex plus f. So ex plus f distribute these quantities and set the quadratic terms equal to each other, set the linear terms equal to each other, set the constants equal to each other to evaluate a, e, and f. So if you distribute a into parentheses, you get ax squared plus a plus, now if you distribute x into parentheses, then distribute 1 into parentheses, you get ex, or x times e, plus, and it has another x, so it gets power 2 plus fx and if you distribute 1, you get ex plus f. So I'm going to just write down plus ex plus f. Very good. So what's happening here? On the left-hand side, I have 3x squared plus 1. On the right-hand side, I have ax squared plus ex squared. I have some linear terms as well, but I don't see any x on the left-hand side. It means that officially it was 0 times x. Okay, very good. So let's figure out what are these. Ax squared plus ex squared must be equals to 3x squared. So the combination of these two must be equal to the quantity on the left-hand side. What's the meaning of that? It means that 3 is equal to a plus e. A plus e. What about the linear terms? Well, here I have two linear terms. I have fx and ex, but it must be equal to 0x. So what's the meaning of that? It means that f plus e must be 0. What else do we have? We have a and f. So here you go. You have a plus f must be equals to 1. Okay. So 1 is equal to a plus f. A plus f. Okay. So what we can do here? We can see that we have 3 equations and we have 3 variables, right? If you take these 2 equations, the very first 2 equations, or from this equation, you can write down f as negative e. Since f is equal to negative e, you can plug that in here, and then you get 1 equals to a minus e. So here I have a minus e. But my very first equation here says a plus e must be equals to 3. So I have 3 at the same time equals to a plus e. So if I add these 2 equations, 4 is equal to 2a plus 0, 2a plus 0, or 2a is equal to 4, or a becomes 2. Very good. So my a is equal to 2. I found my a value. Since I have a, I can easily find f and also e. So if you plug this guy in here, your a is 2, so f becomes -1. If you plug this guy back here, 2 plus e is equal to 3, so e is equal to 1. This is one of the approaches that you can apply. So let's go back to our partial fractions. Copy this guy down and take the integral now. Copy and paste here. So let me erase unnecessary part. And move it a little bit further here so we have enough space. So far we saw that a is equal to 2, e is 1, and f is -1. So I'm not going to copy down anything for e, but here I'm going to write -1. My f was pink. Let me use pink as well. Very good. So we broke down the fraction into 2 smaller fractions. Why is that? Because it helps us to do the calculation, taking the integrals a little bit easier. So the integral on the left-hand side, dx, is equal to the integral on the right-hand side, dx, and then dx. And as you guessed, we're going to break down the second integral into 2 pieces. The integral here is 2 integral of dx divided by x plus 1 plus the integral of x dx over x plus 1 minus the integral of dx divided by x squared plus 1. Remember that the integral of du divided by u is ln of absolute value of u plus c. So if I take u to be x plus 1, du is equal to dx. This integral is 2 ln of absolute value of x plus 1. And then for this integral in the middle, x dx, how can I write this integral? Let's not separate this first, so I show you what you're going to do, then separate them to make it a little bit easier. Before doing that, so this guy is x minus 1 divided by x squared plus 1. This guy can be written as the integral of x dx over x squared plus 1 minus the integral of dx divided by x squared plus 1. So now if you take u sub, u is equal to x squared plus 1, du is 2x dx, all right? So if you multiply and divide by 2, you get the integral of a half ln of absolute value of x squared plus 1. What about the last integral? Remember that if you have the integral of du divided by u squared plus a squared, this is equal to 1 over a inverse tangent of u over a plus c. So when you look at this integral, u is equal to x and a is equal to 1. So you end up with 1 inverse tangent of x divided by 1, or just inverse tangent of x. Don't forget to add constant of integration. And you can say that, hey, since this guy is positive all the time, you can get rid of absolute value. So this integral is 2 ln of absolute value of x plus 1 plus a half ln of x squared plus 1 plus inverse tangent of x plus constant of integration.